This is third episode of RTOS, and in today's episode we will see what is time slicing. So first of all, let us compare time slicing with preemptive scheduling, which we have already discussed in last video. So we will use same setup, same two LEDs, same code structure, everything same. The only thing change is one setting, and here what that one setting actually control, that we're going to discuss. Okay, so here the main setting is a priority, right? In preemptive, what we have discussed is that RTOS give first preference to high priority task. Okay, so we also discussed the example of ambulance. So when you compare normal traffic with ambulance, it will give first priority to the ambulance, because ambulance is must type of task. It means in our code we set its priority it high, okay, while other tasks priority was normal. So the real world example is considered as a one office and one urgent job, a manager versus two equal co-worker. When manager needs something done right now, everyone else simply stop and wait. No negotiation, no turn taking. The manager's work finished completely before anyone else continue. So it's considered like it's a highest priority task. Okay, when manager wants something to be done, the priority would be highest, definitely because of the seniority, or it may be really urgent task. But when it's two core worker of equal rank sharing one desk, right, neither overrank the other, so they quick turns a little work each, back and forth very fast, and both jobs keep moving forward together all day. So it's like some resources is there, and let us say one senior person wants to use that resources. It could be GPU or something, high priority server or whatever. Okay, so since the priority is highest, that person will use, or say that person will utilize that resources first, okay, without any negotiation or without any scheduling or something like that. But when same coworker wants to use same resource, they will use time slicing approach. So it's like, okay, use this for 10 minutes, then give it to me, then I will use for 10 minutes, then I will give it to you, like that. So it will continue back and forth, and that is how both the co-worker has access of the resources with time slicing, or you can say time based term, right? So what actually we'll see on the board in today's this episode, when priority was high, okay, we have already observed that one LED fully stops for 2 seconds, right? Because the high priority task takes resources first, and during that period, during that 2 seconds, normal priority task was completely freeze. Okay, stop, halt, and after completion of high priority task, that task start taking the resources and execute. It starts executing. But in today's video, we will simply change the priority from high to normal, and you will see both LED will completely running independently of each other. So you will see like both LEDs are continuously enjoying their own time period or their own path or their own resources. Okay, none of the tasks will block any other because the priorities are same. Okay, so this is what you will going to see in today's lecture. And as I told you earlier, we will do simply one change. Okay, simply one change. In Cube MX, I will simply change the priority from high to low, high to normal. That's it. Okay, and this is how you will see how it affect the overall operation. So let us open our Cube IDE. Okay, so this is the same code which we discussed in our preemptive scheduling or priority based scheduling. You can see task LED 1 was one LED turn on and off with interval of 2 seconds. Okay, so this is actually busy period, and in priority based scheduling we have observed that during these 2 seconds, this kernel not allow any other task. Okay, so even we have another task where one LED is blinking with interval of 100 milliseconds, which is very small compared to this 2 seconds. But throughout this 2 seconds, this LED will not get any resources, and we have observed this, right? Now we will keep this same as it is. Okay, and simply we will change this priority from high to normal. So we have two options. One, we can do this from this IOC. Okay, this one from here also, and we can also change this from here also. Okay, so for it's very small change, so I'm just changing from high to normal. That's it. I'm debugging the code. Okay, So first of all, let us show you the previous code. So you will see the changes. Now look at the hardware. So this was the initial code. You can see for 2 seconds only one task was executed, right, and another was completely in you can say hold condition, right. And now let me simply change the priority from high to normal. And now let us upload the code. Now you will see the changes. And here you can see both tasks work independently. So nothing like any halt or frozen or something like that. And why this happened? Because now kernel can see the both tasks are having same priority, and as per the default setting, kernel completely change the task with interval of very small period. You can say 1 millisecond. So each task is executing in a sequence, but it is so fast. It looks like parallel or multitasking. But actually, in background, kernel is switching between these two tasks in very small interval, or you can say very fast, and that is why you can see this. So this is what the time-based scheduling, right? So now we have covered priority based and time based. This is for what this video. Thank you very much.